So with alignments, what elements are nothing but, for this, suppose is bidirectional RNN cell, for suppose, or LSTM cell, at t is equal to 0, we are just passing the previous information, we're just passing, and we can just get output at certain steps only. So that is the alignment. Actually at other steps we can take. So this is like, there are variants of RNN and LSTM, like 1 to 1. If you're giving input, we will get output at that cell itself, or we are giving input, we will get at each cell, we will get 1 to many, or many to 1. We will get input for every cell, but output is only to last cell, we can get like that. And again, as you can see over here, we have output over here. Whatever the output is we have got, we'll compare that with ground truth value, and then we'll get the gradient, like dl by dy. So loss with respect to output, that will be back propagated, as we have seen in the RN and LSTM bidirectional series of the AirSketch. And then we will update the weights of the neural network. So like then output weights, so we will update those, and then using those weights have been optimized, and again loss will be decreased, accuracy will be increased. So that thing can be done here, and it can be done over here also, here also, like each cell also, as you can see, 1 to many or many to 1, like that we can do. This is actually many to 1, 1 to many. This needs to be duplicated here also, we need to do, so we can get this one is this. So yeah, now comes to loss calculation. What is loss calculation? What I've said is like, from bidirectional LSTM we will get this matrix like character versus timestamp. So for example, we have x and y, only two characters are there, and we have blank symbol, so that we can avoid that step. And we have given the probability weights which we have gathered from, like, this is an output from the bidirectional LSTM neural network, which we have seen all the previous modules like CNN, bidirectional LSTMs, all the neural network, client server, socket. So those models we have seen previously. So like in particularly machine learning, CNN, bidirectional LSTM, like we need knowledge of base RNN and LSTM that we have seen previously. So we have the character scores, probability scores over here, and the probability range from 0 to 1. And here this sum will be equal to 1, column sum will be equal to 1, as you can see. For example, if we want to calculate the score of xx is nothing but 0.2 into 0.2, we'll get this value, and x dash this thing, we get 0.2 into 0.5, or dash x 0.5 into 0.2. For example, given text is x itself, just x. So given text, it is x, that means in the image we just have x. And after that training step, if we have done, so after the output of the bidirectional LSTM will be this. Now we want to train, or we want to make the model recognize x as x itself. So what we'll do is we need to find the different combination how x can be formed. So one way is dash x. Dash x is nothing but, as we have seen, encoding is one of the encoding alignment of just x letter, and this is again another way. So if we decode it, it is giving x only, it will give x only, and this is duplicated, so it will also give x. So these are different encoding alignments of the letter x. So we want those, some of those we will take actually. So probability score of dash x we have calculated over here, it will come over here, it's color coded, you can see. And for this one we have done over here, and this one we have done over here. We will just sum those, and that will be the score for the letter x. And for example, just blank, it will be just two blanks, that means this thing and this thing, so we'll get that over here. So as you can see that if the given text is assumed to be blank, we have seen that. Now we are now able to compute the probability of given text of a training sample given the output matrix, this one. The goal is to train the neural network such that it outputs a high probability, ideally value of 1, for correct classification. So therefore we maximize the product of probabilities of correct classification for the training dataset. For technical reasons, we reformulate into an equivalent problem, minimize the loss, like maximize the product means nothing but minimize the loss of training dataset, where the loss is negative sum of log probabilities. So in like log y hat, or y will say like binary cross entropy loss or simple cross entropy losses, that only we will use logs, so that like we like underflow, all those will not happen. And again we use minus again before that to indicate its loss. So we, where the loss is negative sum of log probabilities, If you need the loss value for a given sample, simply compute the probability, take the logarithm and put minus in front of the result. To train the neural network, the gradient of the loss with respect to neural parameters, example, weights of the convolutional kernels or bidirectional weights, like RNN or LSTM weights. So those are the weights, like neural network parameters. So those are computed and used to update the parameters. So this is how training intuitively happens in a nutshell. Now what happens is, like, once we have trained and we have got this matrix and we have passed a like some image, we have just these vocabulary terms, so we can take xy, we have just that image xy is passed. Now we need to predict, right, whether it is xy or whether it is what letter. So calculation, the best step, the most likely character by probability. So once we have the probability scores, we can just at each timestamp we will just check which is the argmax over here, which is the highest probability, and then here which is higher probability. Like that we can just form a path or sequence of path, and then just we can by spread we can just write that, and we can just use encoding decoding. Like if you have duplicates, we can remove that, and that's the answer. We can just, because this is a prediction, here we not train, we are not calculating loss function, or we are not updating weights, we are not doing that. We have just got the matrix using by passing our image. We need to predict. Now just we need to give the text, because the model has been trained. So in that model only we are passing the image. So trained model only we are passing the image. So encoding, by first remove the duplicates. So first we need to, like, best character, most likely character score by probability scores or weights, we will just calculate. For example, here x, again x, here for example blank, then again y, if you're blank, so x blank y. So using encoding decoding techniques, what is the answer? It will be xy, because these are duplicates. Once it comes, and we can just break this, ignore this, and y will be coming once. So xy is the answer. So xy is the answer. That is nothing but it's not always true, because for example, most likely probability is over here 0.5 to 0.5, but the given text ground truth value is x. So for this x, we are going to predict this blank. So that's the wrong answer. So sometimes it gives wrong answer because most likely technique is not correct. So we need to use something like average, or trying to see all the parts, all expected average thing, all situations. Those things we need to see. So this is just one of the decoding thing. There are different decoding things actually, like techniques, beam search decoding, prefix search decoding, or token parsing, or again expected sequence or situation, expected weighted average thing, those things. So we will see that. So expected situation or sequence thing, those things are there.